Hello, my name is Dorothy Frazier, and I'll be talking to you about the chaos theory. It has been said that something as small as the flutter of a butterfly's wing can ultimately cause a typhoon halfway around the world. The chaos theory. You may not have heard of this concept before or even know what it is, but it is the root to the knowledge we have on how our weather occurs. Of course, science itself, with astronomers, ecologists, and biologists, they've all had a part in every discovery made. Even mathematicians and meteorologists have partook in discoveries. The chaos theory is a phenomenon created in the 20th century with the new age of computers and the set out to discover ways of how nature works. The chaos is defined as the science of surprises. It is the nonlinear and the unpredictable. It teaches us to expect the unexpected. I will be covering the origins of this theory, what discoveries were made in its honor, and the effect it had on the science world. Edward Norton Lorenz was born in 1917 in West Hartford, Connecticut. He received a bachelor's in mathematics from Dartmouth in 1938 and the master's in math from Harvard in 1940. According to the New York Times, during World War II, he worked as a weather forecaster, and this led to him getting a master's and doctoral degree in meteorology from Massachusetts Institute of Technology in 1943 and 1948. The winter of 1961, Dr. Lorenz was spending the day testing and running figures into a computer model of weather simulations. He had decided to redo a test, but instead of restarting from the beginning, he wanted to start in the middle by inputting numbers from the first run in. Considering that the computer program was the same as during the first run, he figured that the results in the second run would be the same as the first one. But however, when he inputted the numbers, he did not put the whole number, such as 5.123456, he put in 5.123. This small change, a roundation of a number, caused a drastic change in the outcome, and a completely different result. This made him realize that nature is a complex system with an unpredictable outcome. One branch of discovery was the system of an attractor. An attractor is a numerical value that a system tends to evolve in, which is hard to predict because there's a variety of conditions it could start in. An equilibrium is found when information is put into graphs and the system works to solve a problem. An attractor does what its name says. It attracts the growth. In a population, the attractor is what causes people to come to the area, such as a coffee shop or a new grocery store. Another profound discovery, and possibly more popular, is the butterfly effect. The basic concept of this effect is that small changes have large consequences, or sensitive dependence on initial conditions. The future cannot be predicted because many changes can happen from them. The website of MIT Technology Review says small errors regarding large-scale weather features, such as recording an imprecise location for a storm, would double in magnitude in about 3 days. The chaos theory added a new side to the mathematical world by showing that patterns that are found can be disrupted, and any guess made is expected to be disturbed in a matter of hours. Nature does not want to be predicted. Lorenz himself sought out to combine mathematics with meteorology and created the mathematical model of the weather by using a set of differential equations that represented changes in temperatures, pressure, and wind velocity, says the Space Telescope Science Institute. In conclusion, the beginning quote that a butterfly flapping its wing can cause a tornado halfway around the world does not actually mean that. It rather just means that the weather cannot be predicted and it will never know what the cause of it is. That any change in the world can cause something drastically different. The chaos theory was a phenomenon created in the 20th century with the new age of computers, and that was set out to discover ways of how nature works. Edward Lorenz, a man of many degrees, set out to accomplish just this, only to learn that we will never know what to expect from it. Two follow-up insights were attractors, a number and a value, and the butterfly effect, the concept that small changes have great consequences. In the science world, this theory helped show that not even technology can fully know what to expect with our world. We cannot predict nor change how nature works. And while we try to create computers and machines to do such a thing, nature does what she wants, and one thing she doesn't want is to be known.